So the next speaker is Zhenling Jiang. She is an assistant professor of marketing at Wharton School at the University of Pennsylvania. However, she just got promoted to associate professor with tenure. She studied various complex consumer decision making, such as financial decision making, using various techniques, including experiments, machine learning, AI, some econometric models. So today she's going to talk about the effects of ramping up the recommendation algorithm, using combining those kind of techniques. So please welcome.
Hi everyone, thanks for the applause for tenure. This is still quite new, I'm still very happy about it. Thanks for Kasuke for the nice introduction, and thank you for all of you to be here. So in this project, we are looking at treatment effect estimation when we're testing for different algorithms. It's like a bit relevant to what you've seen earlier on the ranking algorithm, but this is in a slightly different context. And in particular, we're not trying to compare two versions. What we're trying to do is kind of have a method framework to say how you can evaluate any of two versions, regardless of the change you're trying to make. This is joint work with Ruohan, who is amazing. She's the lead author on the paper and deserves all the credit. Shi Chao is our industry collaborator from WeChat, and this is very much inspired by the practical challenge that they face when running experiments on their platform. And then Yuchen is a postdoc currently at MIT. Okay. So what do I mean by when I say we'll test different algorithms? So it's kind of safe to say and a little scary to think about that a lot of our consumption these days are driven by how the platform are designing these allocation algorithms. Right? So the type of products we choose to buy, the type of music we listen to, what shows we watch, are very much impacted by what we see on that page when we're landing on the platform. In our particular context, we're going to look at advertising, which is, of course, a massive market. So what do I mean by advertising allocation? So for those of you who use, say, Instagram or Facebook or any platform, TikTok, you are going to kind of go through your content, and at a certain point, you're going to hit what's called the advertising slot. Right? So this is a viewer impression that the platform now can monetize. Right? So the moment that happens, when the viewer hit this advertising slot, there are going to be a back-end allocation models that says, given in my entire advertising inventory at the moment, for this particular viewer impression, I'm going to pick this one ad that I think is going to resonate with this viewer, and I'm going to show this ad for this person. It's obviously very important for the platform, right? So how well it can do this allocation can directly impact how they monetize the platform, how they monetize all the viewer attentions they get. And the operational reality is that because this is such an important part of the platform, the teams are constantly trying to update and, of course, need to evaluate how does this kind of new model compare with our current model. So let me give an example to kind of like the abstract way of thinking what it means when we have two different types of advertising allocation rules. And this is, of course, like very, very simplistic. The way that they work is you can think about the model is trying to guess what is the fit of the ad for the viewer. Like these days, I have a 6-year-old. I see a lot of ads targeted to me about kids' activities in Philadelphia. And they know that because that's the type of things I tend to click on. I purchase, the Peppa Pig shows that they're running, so they know that I'm a good target audience for them. So they do that by trying to predict, what is the click-through rate, what's the conversion rate, and a bunch of outcomes they like to see. So that's how they can match viewer impressions with one of the ads. Okay, now Suppose that in our current model, we're really trying to prioritize people making a click. However, some team are saying that we shouldn't care only about click-through, we should also try to increase our conversions. So now I'm going to have a new model that says I'm going to prioritize conversions. So this is kind of one slight change, and this is kind of like fairly abstract. So what does that do for the viewer impression is that suppose that in my current model, like in the current way to do the ad allocation, I'm going to see this wonderful ad that's going to show me all the sundresses I can get to wear when it's summertime. But suppose now the same viewer impression, the same user, when the model is trying to prioritize the people actually making the purchase, maybe this Nike shoes that is actually having a discount is going to win this viewer impression. So the ad allocation matters because for the same viewer, the same type of ad, I can decide to kind of expose different ads for this particular user. So it matters. What the platform now is trying to decide is when I switch from my current way of doing this ad allocation to a new way of doing ad allocation, what does that do to my advertisers? I care about my advertisers because if they were able to get, say, higher purchases, higher clicks, they're happy to keep coming back and spend money on our platform. So we as platforms, we care about the outcomes of our advertisers. Let's now think about a kind of fairly clean way to measure what we're trying to get at when we say, should we switch from our current way of doing the ad allocation to this new way of doing ad allocation? So how can we do that in a fairly clean way? There's one type of experimental design which is tend to call double-sided experiment, which just means that I'm going to randomize both of my ads as well as my viewers into these kind of two distinct separate worlds. So I'm going to have half of my ads randomly allocated to control, the other half to treatment, same with the viewer. So this is as if I'm running two instant runs. So half user get to do one, half get to the other. So then I'm going to run my previous model in one, I'm going to run my new model in the others. Because things are randomized, I can compare the advertiser outcome in these two conditions. So I may find out if I make a switch, more people make a purchase. That can be one option. And my advertisers are happy, given the same budget, they have a high return. Platform really does not like this. Why? Because this has kind of high engineering costs to even making this happen. And to maintain several versions of my platform. High business costs. As advertisers, I only reach half of the market. That's not great. And also, even just for pure experiments perspective, this is also not great. Because as platforms, I don't have just kind of one experiment to run. I have 10, maybe 100 experiments running at the same time. So as you're thinking about cutting up your market, things can quickly get out of control. So this works, has a bunch of limitations. So what do platforms do instead is to run this advertiser-side experiments. How does it work is, I'm going to have my advertising. I'm not going to randomize my viewers. So advertisers, in theory, still have access to the entire market. Same for viewers. As viewers, I can still have access to all of my potential ads. So how does it work? I'm going to randomize my ads, and depending on the treatment status, I'm going to do this ad scoring, either using my new models or my previous models. And then still one ad gets shown to the viewers. And then the most intuitive way for us to evaluate is to say, I'm going to just compare the outcomes for the ads that gets allocated to treatment and the ads that get allocated to control. Right? So we call them the difference in means estimator. So what we're going to do in this paper is to show that this kind of fairly intuitive way to understand the treatment effect, this difference mean is going to be severely biased. And we're going to propose a new estimator using the same simple experimental design, but try to get at the quote-unquote correct treatment effect estimation to decide, do we go with our current models or do we go to the new models? And one thing I like to mention is that for these type of experiments, we cannot randomize some viewers, like the examples that we heard earlier today. The reason is because the eventual outcome we care about are on advertisers. And we also need to follow a bunch of constraints that are defined on the advertisers, such as they have a budget, they have some pacing. So because of that, I cannot really randomize on the viewers. And if we do randomize on viewers, they also have kind of interference spillover challenges, which I'm happy to get to if people are interested. Okay, so why do we care about this? What's the big deal? I'm going to use our actual experiments. I'm going to cherry pick a statistics that works well for us to illustrate this point, which is, the kind of the short context is run on WeChat channels, which is a short video platform. You can think about like a TikTok type of setting. The treatment is a new ad scoring model, so there's a new way that you're going to do this ad allocation. Similar to the example I was talking about earlier. We are very lucky to be able to measure a ground truth using this double-sided design I mentioned earlier. So this is going to be our benchmark. This is going to be how we check our answers against. This is going to be the solution. Using one cherry-picked engagement scores, we show that using this ground truth measures and that the new model actually does worse. So you should not deploy this model as leading to a worse outcome. Where if we rely on this naive difference in mean that we just talked about earlier, that actually says the new model actually works better. So it is a big deal because it's leading to the platform making the incorrect decision in terms of whether I want to adopt or go back to my previous model. And of course, because of the scale, it's going to lead to them kind of losing a bunch of revenues because they're now using a worse model. Okay. So to summarize, what we care about in this paper is to say, when we need to run these advertiser experiments, how should we think about this treatment effect estimation? How should we think about whether I should use my previous models or the new models? So in this context, the treatment effect is if I go to my new model, the treatment model, what is the aggregated advertiser outcome relative to the control model where I use my kind of current models and the aggregated advertiser outcome. Right? So if I'm Instagram, do I launch or not? So that's the decision. Okay, so I'm gonna try to illustrate what is kind of the core challenge that we see. So why this fairly intuitive compare the two treated and control advertisers doesn't work, right? So where does this kind of algorithmic interference come from? And this is a slide involved, so bear with me. So what happens is that when the treated ads and the control ad are going to be in the same set, competing for exposure for the same viewer. Right? So for the same viewer, the sundress and the running shoes are all going to be in the set, wanting to get exposed to the end viewers. So because they're going to be in direct competition with each other, there's going to be what's called the spillover effect. Right? So you can impact the outcome for the other unit when they're in the same set competing with each other. So in academic terms, this is really bad because it violates kind of the fundamental assumption where you treat it and control should not really interfere with each other. So that's fairly abstract, right? So it kind of seems to make sense, but what exactly does that mean? So what's the consequence when this happens? The consequence this happens is all of these allocation models, recommendation systems, so to speak, are going to be highly, highly personalized. When I go on Instagram, I'm going to see different ads than someone else. And that makes a lot of sense, right? They're trying to target. Let's again think about an example, using our click-through rate and conversion rate example that we talked about earlier. Consumers are different. Some consumers like to click on things without purchase, for example. There can be other consumers that are a lot more likely to kind of buy things on the platform. So let's think about if there's a very kind of high engaged viewers. The platform knows that they tend to make a lot of purchases. When an impression opportunity happens for that viewer, then they're going to be a lot more likely to be shown an ad that comes from, that prioritizes conversion. Relative to a more kind of casual viewers, then they're going to be more likely to show an ad that prioritizes click-through relative to conversion. That is a little abstract. So end of the day, what's going to happen is that for your treated ad and the control ad, you're going to reach systematically different audience. And this is kind of almost by design, right? Because all of these algorithms, they're trying to find their people. They're trying to find the type of audience that works really, really well for this particular pool of content. When they're in the same set competing with each other, what's going to happen is, end of the day, after I run my experiments, I'm going to see that my treated ad reached these pool of audience. My control ad, I can see reach this other pool of audience. And these two types of viewers can be systematically different, and that's kind of the core challenge here. You may think, why is that a problem? Of course they try to find the people that fit, isn't that kind of by design? Why is that bad? It is bad because what we're trying to evaluate as a platform are these quote-unquote counterfactual scenarios where we need to use the model to evaluate the entire viewer impression. So then, this is not going to be kind of, we cannot really evaluate that when the control and treated kind of use a selected pool of viewers. Okay, I know that's a bit involved. Hopefully that makes a bit of sense. This is kind of connected to this thing that I think people start to recognize on Meta or any platform is that they are, when you think you're running experiments, but then the targeting model are leading people in different directions. So end of the day, you reach different audience. I mean, in our case, that can be really, really bad because when we evaluate treated versus control ad with different audience, that can really lead the bias to go in either direction, right? So it's not just kind of either and underestimate, it can really lead the bias in either direction. Okay, so what do we do? What we end up seeing in the experiment are, some are in treated, some are in control. We know the treatment status. We know what actually happens. So we're going to use kind of a modeling approach to say, given what we know, let's run this kind of quote-unquote counterfactual models to evaluate what would happen if we switch from everybody's in treatment to everybody in control to everybody in treatment. So that requires us to understand kind of the exposure mechanisms. Apologies for the Greek letters. This is a way to say let's kind of put a model structure to understand how does the allocation system works given the treatment status, given the viewer characteristics, given the content characteristics. Let's put some structure on it, and we're going to estimate this whole system using the data coming from our actual experiment. And using the models, we're going to be able to kind of simulate out what's going to happen when we are kind of making that switch. So the model, really briefly, is going to be semi-parametric in the sense that we're trying to keep some part of the model flexible because we're working with high-dimensional viewer content characteristics, but we also want to put some structure to be able to run our counterfactual simulations nicely. So I also need to kind of have some understanding of how the viewers would respond if they see some content. And putting everything together, I'm going to be able to get at the target thing I want to care about. Let's skip through this. So what do we see? We ran an actual experiment on WeChat platform. So some useful background is WeChat channels will allocate certain slots for promotional content, very similar to other platforms. As you're sliding through, you're going to see that this viewer hit an ad block, and advertisers will set their budget, and they're now trying to evaluate a new scoring model to determine how to do this ad allocation. It ran for 8 days in June of 2024, involving about 1 million ads. So the way we design experiment is that we are going to randomize both the viewers and the ads in kind of 3 worlds. They're all separate from each other's. So using this global treated versus global control, where everybody kind of just entirely runs the treated, entirely runs the control. So this is exactly just using this double-sided design I was talking about earlier. So this is kind of a nice, expensive, but clean way to measure what's the impact of switching to this new model. And I'm also going to run kind of my standard advertiser experiment, kind of the easy to run experiment. I'm going to collect my data. So I'm going to use these double-sided to measure the ground truth, to get a benchmark, and then I'm going to use the different models to estimate using only the data coming from the advertiser experiments. So we can actually see the evidence of interference using the actual data. So, end of the day, after the experiments, I can see some kind of characteristics or covariates of viewers who get to see the treated versus control. You can compare them. You can run simple hypothesis testing. And it turns out that across these 4 covariates we're looking at, which are all kind of significant prediction of the outcomes, they are indeed significant. So this is kind of one thing you can check using your experiments. And do you actually have this challenge of the viewers being different, therefore that there's this interference happening? We see evidence of that, and we also see that the actual exposure probability is not exactly the same as the assignment, which again is a consequence of this competition, of this spillover effect happening. Okay, so what do we see? What's the outcome? The way to read this is the blue measures the ground truth, so this is coming from the double-sided experiment. And then the orange is what our proposed estimator will do, this D-bias estimator. And then we're going to have this difference in mean, which is how the platform used to measure this, just by directly comparing the outcomes. And we also have a deep learning benchmark, kind of just having kind of pure black box models without any structures. So the way to see this is across the 3 outcomes we measure, the proposed model is always in agreement with the measured ground truth, where the difference in mean estimates can go in the opposite direction, right? So this goes to say that if you ignore interference of treated and control units and you just compare the difference in means, it can tell you the opposite direction of what kind of the correct answer should be. Okay, so I think coming back to here, what we talk about in this paper is it's so common and prevalent for these platforms to run these experiments. It's important. We care about our advertisers. We want to improve our models, and we also need a good way to evaluate. And if we rely on the standard difference in means, it can really lead to these costly mistakes in deployment. It's not just a change in magnitude, it's about directions. So we can think about one way to solve this is by running this costly experimental design, which works but has a bunch of limitations. Or we can think about putting some structure on how interference arises and to have a new estimator using a simple experimental design. We validate that this works Well, using a large-scale field experiment, and kind of the end of the day, what we get is having a reliable way to evaluate from this kind of fairly cheap and standard experiments. And we think that this similar mechanism arises in many other settings besides advertising. I'm actually talking to another platform which have like, similar challenges, and they know that they cannot really directly compare, and they want to have ways to be able to evaluate and more cleanly. So when we think about online marketplace, when we think about even offline retails, whenever you have treated and control in competition with each other, to ask yourself, do I have spillover challenges? Do I have interference problems? And that's all I have. Thank you very much.
One question? Any questions?
You haven't already proposed to reach out to adopt this at scale.
You mean on their platform? Yes, so that's why we have like an internal person. Yes.
I guess my question is, are they going to adopt this at scale, or have they already, in case you're at liberty to talk
My
about it?
understanding is they have already. So they care a lot about this because the way they work is they test something on a small scale first, and the individual team, their bonuses are tied to the performance when they launch full out. And they have found time and time again the result will flip when they scale up, which is again a consequence of this interference. So they are very much incentivized to have the correct way to evaluate.
Thank you.